Hello, everybody. Be welcome to the session 4A of the ICCCBE and CIBW 78 conference. I'm Eduardo Isato. I'll coordinate this session. In the session, we will have 12 papers, and the session is divided in two parts. The first, with 5 papers, we cover the topic of BIM for planning and cost estimating. And the second part will cover the topic BIM for infrastructure projects. Between the parts, you have a slot for question and answers for the first part, and at the end of the session, another slot for the following 7 papers. So we'll start with the first paper that is from Luis Reinaldo and de Azevedo Cardoso, that is titled Strategic Planning of Work and Use of 4D BIM for Multiple Forms.
Good afternoon. My name is Luis Reinaldo Cardoso. The others, I'm professor in Polytechnic School, University of São Paulo. The others authors are Thalita Rios, Thierry Monhol, and Vinicius Marostica. The work is Strategic Planning of Work and the Use for the BIM in Strategic Planning. The context, objectives and methodology, literature review, conceptual considerations, case study, results and discussions, conclusions. Context. Little emphasis on consideration of local realities, particularly the real estate market in Brazil. Few documented applications about 4D BIM in the initial stages of the project. The advantages of consideration of local realities, needs for the BIM, support in decision, little emphasis on consideration of local realities, few documented about application, about 4D BIM in the initial stages. In this stage, modeling can be simplified. Objectives. Propose and demonstrate the viability of a method to use 4D BIM to support strategic construction planning decisions. Methods, literature review, conceptual considerations, and the presentation of a case study. Literature review, databases Web of Science and Scopus, sample to analyze the content, 22 articles. Next, please. Many articles with focus on control, not the scope of the present article. Focus on overcoming the technical barriers caused by the usual practices. Little emphasis and information related to the more general context. One article with approach to use in this article. The main difficulty cited was the complexity of 3D modeling. One article recommended use for the BIM at the beginning of the project. Strategic planning, ethic planning, is general planning for the execution of the work. Can be expressed in a basic schedule. More than one attack plan can be developed for analysis and definition. The planning techniques considered are Gantt chart, PERT CPM, precedence networks, and line of balance. The planning techniques have been able to support planning needs. Its main limitation is the difficulty of interpreting the schedules. 4D BIM allows to receive isolation of the building construction. 4D BIM doesn't replace the usual techniques. It needs should be connected with this. It is necessary modeling from the to-do CAD and complementary elements and equipments. In the strategic planning, it's possible modeling only critical paths with simplified modeling, and the planner can do it. Case study: construction of a medium standard residential complex, 3 towers with 10, 50, and 20 standard floors, 270 apartments, built area about 39,000 square meters. The 3 towers will be built simultaneously with a gap of 30 days. The question is, to which tower to start, the biggest or the smallest? Proposal: simulating the two alternatives in 4D BIM. Modeling from to-do CAD in Revit with 3 towers, external ground, complementary elements. Simulation and with Navisworks, with import files made in Revit and the schedules made in project. Images of the visualizations. On the left, initial works. On the middle, plan 1, start by the largest. Plan 2, start by the smallest. And on the right, the complete work. Results and discussions. Plan 1, 22 months. Plan 2, 24 months. Visualization present good general quality, provided decision. The main difficulty is the modeling time, also reported in the latter review, increasing from about 150 to 600 activities each plan, all modeled. The total expenditure can be compatible. Conclusions: feasibility of applying the 4D BIM with methods and tools used. 4D BIM requires the current use of the usual planning techniques and tools. The planner also be to model 3D and use the 4D BIM tools. The main difficulty is the modeling time. Recommendations were done to this. Thank you.
Thank you, Luis Fernando. Thank you very much. The next paper will be presented by Miriam Caroline Farias Santos, that is titled Conceptual Framework for Integrating Cost Estimating and Scheduling with BIM.
Greetings, everyone. My name is Miriam Santos. I'm a researcher at Bahia Federal University, UFBA, and today I will present to you the work named Conceptual Framework for Integrating Cost Estimating and Scheduling with BIM. This work has as co-author Diana Basto and Emerson Ferreira, both a professor at UFBA. Next, please. First, I will give you a brief introduction and outline of integrated scheduling and the cost estimation with BIM. Then, I will explain the research method and the findings, to finally share with you the conclusion. Next. Construction projects involve many people, usually work separately in different stages. For this, fragmentation represents a common problem. Many studies have emphasized the benefits of integration using BIM. However, there was no consensus on a typical workflow to integrate different processes in construction. This work proposed a conceptual framework with assumption for integrating 3D BIM modeling, cost estimating, scheduling, and monitoring processing workflow. And they also provide some requirements to evaluate the integration between these. With an integrated workflow, it's possible to share information and activity through people, processes, and technology, resulting in improvement in transparency, communication, collaboration, and coordination. Cost estimating and scheduling integration must be through a single controllable parameter, since they share some common data, as research and the quantitative. The work packaging model facilitates the integration once it uses cost and scheduling in a single parameter, the WBS. Other requirements to foster integration with BIM are develop 3D modeling according to WBS, integrate different software, link time and cost data to model components, and always focusing on automation. And the use of a single platform to link cost and planning information. A case study took place in 2 projects. The company used the software Revit, Navisworks, Project, TOTS, Excel, and the CP Obras, a customized software. The study studied me to answer the following question. How is the workflow between BIM modeling, scheduling, cost estimating, and monitoring process? What's the problem commonly difficult integration? There is also a literature review to understand how to improve and evaluate the effect of integration. Next, please. The main activity in the project 1 were the modeling, planning, cost estimate team received the 2D project in the office. Long-term plans is sent to field staff. Mid and short-term planning is integrated to monitoring software, and the real data is sent to the monthly report. The difference from project 1 to project 2 was the use of a quantity copy of BIM, and the sum adjustment and activity sequence uses some field data. But in the project 2, there was no long-term planning and a defined work package. Next, please. The most common problems were planning centralizing in the office. There was a lack of work package based on field activity. There was no use of a single WBS standard. There is a need of a single platform or tool to integrate all process. Also, there is no integration with BIM modeler to develop a useful model, and the real costs and the planning data were not integrated with BIM. Next, please. In the conceptual framework, the integration of process must be one by one, encompassing people and the technology. Then, the integration could be accomplished fully. In 3D BIM model cost estimate integration, one has to consider the number of 3D BIM elements and how the estimation program captured and used this data. To schedule, monitor integration, you have to pay attention to how the work package will be organized and how the production data will be collected in the field. In this way, feedback will be more agile. In 3D BIM modeling, scheduling, monitor integration, you have to try and connect as hard as possible the BIM elements with the work package. Then it will be possible to use the 4D simulation. To cost estimating, scheduling, monitor integration, it's necessary to take into account work package and how cost data can impact the schedule and vice versa. In this way, it's more effective to control costs and deadlines. Next, please. Some requirements for integration are automation and simplification that are necessary to reduce the number of activity, people, and technology. If you know people responsibility, it's easy to assign tasks and request quick feedback. A single database to centralize information and make this information available to everyone is a great idea. Making sure that there is communication between office and the field team, and interoperability is important too, as well review and update cost and schedule data. Finally, based on conceptual framework and the requirements, the construction companies can carry out a diagnosis of integration, as well evaluate if there are any improvements after implementing integration. Thank you all for your attention.
Thank you very much, Miriam. Thank you for your presentation. Okay, the next paper is from Sérgio Leal Ferreira, the paper 43, and the title is SINAP and CPOS Reviews Proposal to Effective BIM Incorporation of this Measurement Criteria in Public Works.
Hello. Thank you, Isato. Well, I will show you work made with Rodolfo Pereira and with Reinaldo. That is a proposal of review of two main criteria used in Brazil public works. Then this work is part of a wider study, and it is necessary to explain that SINAP and CPOS are classification, price collection, and work measurement criteria used traditionally in CAD base in Brazil. As the BIM started to become more spread in Brazil, the public government once started to the efforts to include BIM in the public works, and these are the main efforts that we can pick. Well, a large volume of existing public works is here now in Brazil. This table shows 93,000 public works only in two main government programs, but only a few are with some kind of BIM approach. This work then, this study, it was used the price bulletin CPOS and SINAP to experience and analyze the BIM inclusion in public works. SINAP, for example, is mandatory in works that uses federal research and or contracts involving public or mixed companies. It was found that is high desirable as simplification and in their propositions for the user with BIM. For example, SINAP has 32 types of rough cast. This is a huge number, and this variability occurs due to the need of an application place for a definition in this criteria, and this is leads to variation in productivity, in remuneration, in the changes in application tools, and so on. I believe, okay. Too many variables created great difficulty in BIM classification processes, and a very small flexibility for the builder to make your propositions. Then we noted that if we only it changes a little bit the net of possible rough cast, for example, and this is the net, the process tree of the definitions of rough cast. If we take off the need for the definition of the place in the rough cast, for example, we drop from 32 to 6 types of rough cast definition and classification. This is quite good. This is quite necessary to do a job effectively, be done with productivity in this kind of public works. Here is the definition of the composition of these kind of services in the public works here in Brazil and SINAP, and in this case in SINAP proposition. Next one. Well, this research, it was conducted with a design science research method that proposes to build up prescriptive artifact and to solve a real problem. Then we model an actual penitentiary project at the São Paulo State. This model was elaborated from the CAD to the information, and is under construction now. What it means that the actual costs and service quantities will be used to model the consistency verification afterwards. And this is a kind of construction very modular. And here is the figure to illustrate the model. Is very modular and is applied in some, I don't know the number exactly, but it was applied in another constructions, and then we have so much information about the execution of this kind of work. A Revit classification manager was used, and we noted a limitation in the classification of composite objects. For example, the layers it's not possible to classify layers separately, and we saw an alternative to overcome these difficulties. Here is another illustration of the application of the classification manager of the Revit, and we saw tabs in SINAPAIA and CPOS classification informations. The aim, at least, is to make the most precision and consistency cost provision, but nevertheless, it's very common to, along the construction, to occur increases, and it's due to the number of issues. But in Brazil, there is no inconsistency classification. It is an error. It was an error. It exists as an error classification, but we, as a byproduct of this research, intends to propose a classification of these inconsistencies and resumes in 4 types of inconsistencies. Here is the type 1. I don't have time to explain, but the type 2 is the lack of interpretation, that in this leads to an inclusion of additional services, those causing a double remuneration, we call here. The type 3 is an inconsistency that occurs through a global analysis of the bidding, and we cross some informations and concludes that it generates a need for a non-applicable execution process. And the type 4 is due to a lack of further information. The budgeter have the description of the services and the description is not quite good, and he tends to choose the minor price, and this is not a good, real good. We observed the possible advantages of simplifications in lots of services, and this research also think that we can give you an experience guide of an adequate simplicity and the classification of the elements for budgetary purposes in public works, and the ability of analyzing the bidding spreadsheet with these classifications. Thank you very much, and sorry for the rush.
Thank you, Sergio. Thank you very much. The next the next presentation will be from Samin Mahdavian. Did I spell correctly? On behalf of Ming Lu, and the paper is Time-Cost Trade-Off Optimization, Incorporating Accident Risks in Project Planning.
Thank you. you. Thanks a lot. Hello, everyone. I'm Sami Medevi. I'm presenting on behalf of my colleague Moin Sadabi and Dr. Ming Lu, my supervisor. I'm doing MSc research with Dr. Lu at University of Alberta to advance TCT with safety. And I just wanted to take time and thank OHS for their financial support. A cost-effective project planning method is desired to reduce the project cost and duration while maintaining an acceptable safety level. Although there are many studies addressing safety and time-cost trade-off optimization separately, less attention has been given to the effect of accident risk in connection with tackling the time-cost trade-off problem. In this study, the evolutionary algorithms is utilized as the optimization tool to solve the newly formulated time-cost safety trade-off, which we call a TCSD optimization problem based on a case study. Next, please. The risk index is multiplication of accident severity and likelihood. The likelihood and severity vary from 0 to 10, 0 the lowest and 10 the highest. These numbers are entered subjectively by an experienced safety officer. The higher the RI score, the higher the accidental risk. And you can see the formula on this slide. Next, please. The methodology of this research contains 7 steps. First, we calculate the risk index. Then we're going to apply the CPM. After that, we're going to calculate the desired project duration, which we call a DPD. And then we're going to calculate the cost slope and risk slope of all activities. The formula of cost slope is in this slide, and risk slope will be in the next slide. Number 5 is we reduce the duration on selected activities which are on the critical path. And number 6 is in order to add the accident risk to the model's objective function, a conceptual risk penalty cost, which we call it RPC, is set in this research. The decision variable, which is R, is the amount of the reduction in the duration of an activity, and the objective function, which is T, is minimizing the total cost of the project. And there are 5 constraints in this research, which you can see in this slide. Next, please. The TCSD problem is formulated as a nonlinear programming model. The model is analyzed by using the solver software to minimize the total cost and risk of the project. In other words, in this slide, I want to show that how to use the Excel solver to calculate the T, which was the minimum of total cost. In this slide, I want to show the risk index setting for normal duration and crash duration. As you can see in these 2 tables, S1 is low in risk index, S2 is high, and S3 is moderate in risk index. A case study of a 1-story building project demonstrates and validates the proposed decision-making. In all scenarios, duration and cost of the activities remain the same, while the risk index setting and risk penalty costs are varied. You can see all the 6 scenarios in this table. The AON of the case study is presented in this slide, and also to let you know, the total cost of the project is $543,000, and the project duration is 100 days. All activities are normal in this table, and the indirect cost is $2,000 per day. The base case scenario is presented in this table with 0 risk index with no imposing safety cost. The normal project time, as I mentioned before, is 100 days, and the optimum solution has occurred after 4 days reduction. It means that the optimum solution is for 96 days. In this slide and the next slide, there's a comparison between scenario 1, 2, and 3 with same risk index setting, but different risk penalty cost. The aim of these 2 slides is to show the effect of RPC in the total cost. Next, please. The results from the 3 scenarios with the same risk index and different RPC that sequence of crash activities varies. Also, total project time and total cost, which is the sum of direct, indirect, and RPC, are affected. This is another case study, which is I want to show the comparison between scenario 1, 4, 5 with different risk index setting, but same risk penalty cost. In other words, I want to show the effect of a different risk index setting in the total cost. Next, please. Comparing the results of scenarios with different risk indexes and same RPC, which was $25 if you saw it, shows that sequence of crash activity has changed, but the total project time and cost has remained the same and it is not affected. You can see all the scenarios with the risk index and with the RPC together in this slide. And I want to show that the risk indexes affect the selection of crash activities and the final optimum solution of TCST. Next, please. The graph shows a risk index and duration for scenario 1 with $25 RPC and scenario 2 with $250 RPC, both but with the same risk indexes. And the higher RPC makes the optimization model more conservative, while lower RPC lets the model take more risks. There are two conclusions for this study. The first one is adding risk to TCT would impact the optimization outcome and sequence of crash activities. And the second one is with a proper risk assessment scheme and a proper risk penalty cost setting, accident risk can be incorporated into the TCT optimization. And there are three limitations for this study. The first one is risk index setting is entered subjectively by safety officer and it is not formulated. RPC setting is based on trial and error, no formal approach. And the third one is the optimization must be formulated, solved specifically for each particular project. Thank you, everyone, for listening to me.
Thank you, Samin. Thank you very much.
You're welcome.
The next paper to be presented is from Pedro Bezerra, and title is A Materialistic Procedure Combined with 4D Simulation as an Alternative for the Scheduling Process of Housing Complexes. Be welcome, Pedro.
Good evening, ladies and gentlemen. My name is Pedro, and today I'm going to be presenting the paper I wrote in partnership with Professor Sergio Scheer in the Federal University of Paraná in Brazil, called, as said, A Meta-heuristic Procedure Combined with 4D Simulation as an Alternative for the Scheduling Process of Housing Complexes. Can go. Next. Recent research has shown an increasing adoption of concepts from the field of operational research in the construction sector, such as genetic algorithms and discrete event simulation. In the context of housing, there's a great potential for the application of operational research due to the repetitive nature of these projects. Next. The line of balance method is so the most used method to schedule repetitive projects. However, its application still requires a lot of work time. Since the traditional scheduling methods are not very efficient, operational research techniques offer an opportunity to improve the decision-making in these types of projects. Techniques like genetic algorithms have been applied mainly to the process of scheduling activities, using most part of the time the resource-constrained project scheduling problem as a mathematical model. Which can be formulated mathematically as follows. The objective of the problem is to find the precedence and resource feasible completion times for all activities such that the make span of the project is minimized. Next. The genetic algorithms are a class of procedures inspired by the genetic evolutionary process, and it uses three main operators. The crossover operators are used to mix the genetic information of the individuals, the mutation operator acts as a way to increase diversity in the populations, and the selection operator controls the population's reproduction by selecting the fittest individuals. The proposed approach is presented in three parts. The first is the problem modeling, where the following assumptions for programming are defined. The activities of the project are represented by an activity on a node graph and are linked by start-finish relationships. All known information about the project is deterministic. only one mode of execution is considered. All activities of the project are considered repetitive. The production rate of the project is considered constant, no preemption is permitted, and there's a resource limitation to be taken into account throughout the whole duration of the project. Can go. According to the assumptions presented, the logical structure of the type of project addressed is obtained by means of an oriented graph, where the nodes correspond to the activities and the arcs represent the interrelationships between them. However, this representation is not the most appropriate when scheduling repetitive projects. Therefore, the study implements the method presented by Ishihara, where the oriented graph technique is used to model the relationships between activities of a single housing unit, and then the line of balance method is applied to determine the time of completion of all housing units. Next. The second part of the presented approach is the optimization model, where the genetic algorithm is implemented and its parameters are defined. For the population encoding, the individuals are represented by a list of activities. The assessment of the fitness of individuals is made by an adaptation of the serial method presented by Kolish and Hartman, considering the line of balance method. For the selection of individuals, the elitism and tournament operators were chosen. And finally, the one-point operator is used for crossover, and the inversion operator is adopted in the mutation phase. Next, please. The final part of the method proposed is the simulation model. This step is important because solutions determined by the algorithm are abstract and don't take into account spatial and constructive conditions. Therefore, the algorithm-generated schedules are extracted to CSV files, which can be directly imported to Autodesk Navisworks to perform 4D simulations. To test the efficiency of the algorithm, 45 instances from the PSP lib were randomly chosen, and 10 rounds of tests were performed for each. It was observed with the experiments that the algorithm is capable of generating better solutions over the generations. However, as the size of the project increases, so does the difficulty of finding good solutions and the required computational time. 3 groups of 3 instances were also chosen to verify the behavior of the algorithm until the last generation, in order to evaluate both its efficiency and the ability to improve solutions. For all of the instances, it was possible to observe that the ability of the algorithm to create better solutions, which is mainly due to the choice of the selection by elitism that prevents the best solutions found from being discarded. Next, please. As a way of exemplifying how the line of balance calculations presented previously can be applied in the optimization process, a simple standard project from the Brazilian government's housing program Minha Casa Minha Vida was used. Altogether, 100 housing units were modeled for the simulation. Next. The files in CSV format generated by the algorithm can be directly imported to Autodesk Navisworks, as seen in the picture. Next, please. And the final simulation could show that the generated schedule respects the precedence relations between the activities and also demonstrates that the line of balance logic was well implemented in the schedule. Next. Well, in conclusion, the experiments performed showed that the system created is relevant mainly as a way of reducing the human effort when scheduling repetitive projects, since in a few seconds it is possible to obtain a schedule that considers both work continuity and resource limitations. Simulation comes here as another tool to assist in decision making, since several possibilities generated by the algorithm can be tested and even modified through the thousands of functionalities in the BIM-based construction management software. The system can, however, still be improved, since for projects with large numbers of activities, the computational effort required was still very high. And that was all. Thank you very much for your attention.
Thank you very much, Pedro. Thank you. So with these 5 papers, we start the first question and answer slot. So we have question for, let me see, for a that is from Christina. Just a moment. I'm fighting the platform. Yeah, this one. This is to Miriam. Miriam, did the authors test the proposed framework in a case study?
Okay. We use conceptual framework to visit a method to integrate 3D BIM modeling, cost estimating, scheduling, and also monitoring in a case study. It was a product of my master degree. In this case study, we practice two assumptions: the 3D BIM modeling, cost estimate integration, and the scheduling monitoring integration. And there are improvements in implementation and the mostly definition of the work package, resulting in less changes in the field.
Okay. There's another point that from Christina that, yeah, this one. 3D BIM models generally do not consider temporary facilities such as formwork and scaffolding. Any comments on this?
Okay. In the conceptual framework, we don't consider the temporary activity, but we use some block in Revit. We models block to simulate temporary facility in the activity. So there are some WBS to simulate these activities.
Okay, thank you. I'd like to extend this question also to Luis Fernando. Just in the case, did you use or consider some kind of temporary facilities in your study, or what do you think about using this for strategic planning, production planning?
To who, Eduardo?
Sérgio?
Yes, to Luis Fernando.
Reinaldo.
Sorry, Luis Reinaldo.
Please repeat, sir.
Did you consider the possibility of using temporary facilities such as scaffolding and other installations in your kind of study?
Yes, this kind of elements were modeling because it is necessary to visualization these activities. It is all modeling. The increase of the actives for modeling caused by this kind of element.
Yeah, of course. And I just asked because this may impact the choice of choosing one another sequence, because sometimes the place you have to store some materials or something like that, so it's change the site layout. And by the way, did you consider to reducing the LOD or using a less well-defined modeling with fewer objects to make it to reduce the effort of modeling effort that you mentioned?
The final question.
Could you use a lower LOD in order to reduce the effort, the modeling effort to your approach? Because you mentioned 350 activities or something like that. It's a lot.
Yes, the initial points are the simplified modeling.
Yeah.
In the attack plan, it's possible. Okay, and also the active temporary it's possible also to simplify the modeling. This effort reduces the time of modeling.
Okay.
It is possible, and we demonstrated that it's possible. The increase of modeling, where the increase of modeling, but the total expenditure we consider compatible with the funding for the work.
Okay, thank you. We have a question from Rosinea Melo for Sami. That is, did the authors consider to analyze the impact of TCST based on resilience engineering perspective instead to associate the TCST with the risk index?
Actually, as much as I'm aware of this paper, because I'm not the author, is that they haven't used the resilience engineering perspective, and it's only the integration of time cost trade-off with safety. But if you have any, if you are not being answered to this question and you think you have more questions regarding to this, I can write this down and ask the author to answer you back.
In the forum.
I just like to remember that you can, if you want, you can post your questions in the forum at the Moodle. So I also want the authors to take a look after the session to see if there's some question there to answer directly to the people who's making the question, okay? There's another question from Christine, also to Simon.
Yes.
It is actually for me. It is actually for me.
Yes. Sorry. Pedro.
So, well, she's asking if the assumption that the dependency relationship between the activities start to finish is something that happens in these kinds of projects. And yeah, in the projects we that are in which we were focused, we've focused on the work. There are like simple projects from housing programs. It happens, but in these kinds of projects, many kinds of dependencies can happen as the complexity of the projects increases. But all of the assumptions used in the work are based on real on things that happen in the real world. So yeah, it happens.
Okay. I'd like to make a question also to the second Miriam, that is about Sabine model can be very dynamic. Do you think so? So as well as the construction plans. So how do you think you can manage this change in the model considering this integrated environment? When changes happen, how do you think of manage the way to manage this? To Miriam.
She's without microphone.
Okay. So
I don't know, she's talking.
Okay, I'll post this in the Moodle, okay, in the forum for her answer. So I think you are okay with the questions. Anyone more? No?
Okay.
So thank you very much for your presentation. So we can go for the second part of the session. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you very much.
Thank you very much.
I will go. Tem que sair.
So we start the second part of the session that is about the topic of PIN for infrastructure projects. So we'll start with the paper of Stefania Limpunis Correa, that is BIM support in the tendering phase of infrastructure projects. Just a moment. We're having some problems, some issues in loading the slides, so have to wait a little. So I'll take this time to remember you that you can post your questions even after the session in the forum at Moodle, so the authors can access the questions and then answer when it's more convenient for them. So I think that the forum is a good place to exchange ideas also. So it's a good point to take these things alive during some time. So it's a good channel of communication between people that is assisting, that is seeing the presentation of the author. Okay. Still loading. Okay.
Are they there?
We are waiting for the slides.
Okay.
Okay. In this part, we have 7 papers about infrastructure projects. Probably a technical issue with some slides.
If I can help with something, just let me know.
Yeah, I'm just waiting for it.
Okay.
I don't have this kind of control.
Okay. I gotcha. Anyone else do it for you? Okay.
1 minute.
No problem.
I think that the people in the back room deserve an applause because they do a lot of many things here at the same time. Okay, I think it's going.
There we go. So hello, good morning, good afternoon, good evening, depending where you're watching me from. My name is Stefania, and I am a master's student from the University of São Paulo, Brazil. I'm presenting today the research on BIM support in the tendering phases of infrastructure projects. Next, please. Let's begin by a well-known graph where we can see the construction productivity, the orange line, has barely grown in the last decade. This scenario induces to an increased adoption of technology and automation, and building information modeling is therefore gaining relevance. Next, please. BIM can be defined as a modeling technology and associated set of processes to produce, communicate, and analyze building models. However, while there are numerous examples in the literature regarding BIM adoption during the design, construction, or operation stages of asset lifecycle, there is a gap concerning the tendering phases. The tendering process can be divided in three major sub-processes: classifying construction products into items, quantifying, and finally pricing them. Tendering always revolves around dealing with uncertainty, which can be interpreted as hazards or opportunities. In this scenario, the aim of this research was, through a literature review, to answer the question: what are the potential benefits of adopting BIM during the tendering phases of infrastructure projects? The databases used were Web of Science, Science Direct, and Scopus, together with the queries relating BIM to bidding or tendering, planning, and risk management. The bidding stage of a project often requires estimators to do the interpretation of 2D documents, manually extracting information to cost estimations. It is common that information during the bidding stage of a project is not accurate, not complete, which, added to human limited capability to process information, can generate a significant amount of uncertainty. The accuracy of the interpretation needed often rely on the estimator's experience, resulting in a time-consuming and error-prone process. Therefore, finding ways of reducing this uncertainty by decreasing manual activities would result in a faster and more competitive bidding process, and BIM has a potential regarding all these aspects. As mentioned before, one of the first steps when tendering is to do quantity takeoffs. We know that the use of BIM models enable ultimate material takeoffs and schedules, but some aspects has to be observed. The model has to be compliant with a specific set of rules and conditions, and that is why using standards is of primary importance. Customization is also advisable to generate more complex results. However, these are subtle aspects that are not quantitative but qualitative, as movements or the complexity of some concrete shapes. Another important aspect to be taken into account is that the design is not always detailed during the tendering phase, being developed later in the process. Knowing that communications is a sensitive point when different stakeholders are involved, data transfer and interpretation can be seen as risks. Using open data formats is useful to assure that information is correctly transferred between different applications. We also have to bear in mind the importance of the designer knowing the construction methodologies so the BIM model produced meets the requirements and guidelines provided, and quantities and costs are on a solid base. Doing an ultimate rule checking is a request on this matter. Regarding risk management, BIM can promote earlier uncertainty tracking, functioning as a more collaborative and integrated delivery method. By using BIM, risks can be reduced and high-cost expenses are prevented, as well as expensive contingency plans. The main barriers to BIM adoption on risk management are: construction supply chain is very fragmented, so collaboration and cooperation are still a challenge. The bidders are also very competitive, which can prevent integration and collaboration. Some report that having no client demand can prevent BIM adoption as well. But adopting BIM also creates new risks. The use of different software and platforms can pose, in certain cases, a challenge regarding interoperability. Collaborative and cloud solutions demand data security analysis and legal liability updates. Next, please. The literature also indicates that using BIM in bidding activities related to planning is advisable to reduce uncertainties once schedules rely on a great basis on the experience of engineers, and they often do not consider spatial and dynamic information. When BIM is used, doing dynamic clashes procedures can help detecting these errors. Discussing Gantt-based schedules is not an easy task, so 4D planning is also recommended. Therefore, the main benefits of adopting BIM for planning purposes are providing a better time and cost controlling, as well as a more visual progress monitoring, culminating with better planning outputs and communication. On the other hand, the barriers regarding the use of BIM in bidding activities related to planning are: studies report difficulties when linking objects to tasks and to maintain the simulation updated. The lack of standards for representation between softwares is also mentioned together with cultural aspects like responsibility sharing for the planning. To sum up, the bidding process is a result of the interpretation of documents using assumption and hypothesis, requesting bidders to deal with subjectivity and uncertainty. This process can also be very manual, time-consuming, and error-prone. During tendering activities, the use of BIM can help reduce uncertainties regarding the project scope and its planning by giving participants a better understanding of the process and automating manual tests like quantities, takeoffs, and promoting a more visual planning process. By consequence, risks and contingency plans are reduced, and the bid, therefore, is more competitive. The main obstacles to BIM adoption during tendering phases include interoperability issues and a lack of standards. Culture should not be ignored once responsibility has to be shared between team members and stakeholders. Developing research on BIM adoption during the bidding stages is also encouraged to reduce this gap, especially on infrastructure projects. Thank you so much.
Thank you very much, Stefania. Thank you very much. So the next paper is be presented by Sara Nunes, and the title is BIM Component Library for Subway Public Works. Your microphone is muted. Yeah.
Oh, hi. Hi, everyone. I am Sara Nunes, and this paper is enjoyed forward with my advisor, Professor Sergio Leal, and graduate student Jéssica Brito. The aim of this paper is to discuss and propose solutions for the introduction of BIM component library in the Brazilian context of contracting public works. The research method adopted is design science research. Currently, Brazilian public companies contract engineer and construction services through a bidding process, which seeks to ensure the most advantageous proposal for the government and to avoid overpricing in operation. However, it's not uncommon to find irregularities in management of research dedicated to this area, such as overpricing, delay in competition, or even cancellation of projects. In light of this context, some public initiatives of BIM adoption for public construction aim to increase the quality of projects and optimizing budgets, resulting in a greater transparency and information flow control. The present work focuses on the contracting process of Metrô, the São Paulo State Subway Company, which has several contract regimes. However, the Law 13,303 established that in case of engineered works, it must use semi-integrated contracting. Under the semi-integrated contracting, the contracted companies are responsible for the development of the final design and execution of the work. To bid for works, it's necessary to prepare the basic project, which provides inputs for the bidding plan. However, the law doesn't establish the level of accuracy of the basic project, and as a result, it can generate an increase or decrease of 25% in cost in cases of new buildings and 15% in case of renovation. So, to accelerate the contracting process and provide a better project development, our study proposes a BIM component library. This library includes complete modules for subway station. Based on standardized solutions, design solutions, these meta components are modeled and composed by BIM objects certified by the Metrô. The element and materials of the meta component are connected to reference table for cost estimation. And in order to be used in different projects, the meta component must be parametric. Subway station projects have a large number of standardized solutions, elements, and materials. The same construction pattern can be seen through the strata of a line as shown in the figures. Metro has developed detailed elements that are specified in the design standards. These architectural and furniture elements were modeled and serve as an important tool for the development and analysis of projects. In order to streamline and increase the quality of the budgets, all the elements, materials, and objects of the meta component will be related to spreadsheets. The proposed meta component must have parametric that make these predefined models fit in different projects. The study raised several parameters, such as the construction method, the demand estimates, and the depth of the station. The figure shows an example of parameterization of a platform. The parameters highlighted in the presentation inform the size of the platform tunnel, the diameter of the well, and the vertical circulation elements. From the start of the standardization of station, it was possible to structure the component library according to the construction method or the function of the spaces. The group of deep containment structures contains the meta component with the deepest underground part of the station. Shallow containment structure often need adjustment according to the local urban layout, so they aren't part of the meta component. The first meta component developed belongs to group A. From this development, the parameters and rules for this type of station were established. This first model has already shown some challenges, such as the parameterization of the components according to the rules raised, and the relationship of the items with the reference tables. The library validation step will be performed shortly. It is expected to prove that the organization of standard projects in a parametric bin library brings benefits as it will optimize of project development and increase the quality and transparency of bidding process. Thank you for your attention.
Thank you very much. Thank you, Sarah.
Thank you.
So we go to the third paper that will be presented by Aline Valverde Arrotea, and the title is BIM in the Pre-Construction Phase, an Infrastructure Project Case Study. Hello, Aline.
Hi, Professor Eduardo.
Let's go.
Okay. Hi, everyone. My name is Aline. I am a PhD candidate at the University of São Paulo, and I'm going to present the paper named Being the Pre-Construction Phase, an Infrastructure Project Case Study advised by the Professor Silvio Melhado. Construction companies are looking out for the best strategies to implement BIM into their process to minimize problems related to the design and construction interface. Our goal was to understand the main obstacles with BIM adoption during the pre-construction phase in a complex infrastructure project. The paper is a preliminary result of an ongoing research and was structured in 6 main topics divided in introduction, literature review, methodology, case study, results discussions, conclusions, followed by funding, acknowledgement, and reference. The methodology was exploratory and qualitative through a single case study approach. As source of evidence, we adopt bibliography, project analysis, interviews, and informal conversations. The unit of analysis were project, company, and people, and the geographical scope was national. The research was developed in 4 main steps. First, we concentrated on literature review and on the selection of the company and the project to be studied. Second, we focused on the company and project analysis. Third, we interviewed key stakeholders in the company. And lastly, we focused on data analysis. Data collection was made from September to December in 2019 and gathering by using a research protocol. The research protocol contained 2 different questionnaires which were applied based on the stakeholder position in the company and in the project. During the interview process, we applied the first questionnaire to the stakeholders who had participated in the implementation process, and with the second questionnaire, we interviewed the stakeholders involved in the design and construction phases to understand the main barriers related to BIM adoption in the project studied. The selected company is a relevant and well-known multinational Brazilian construction company with over 70 years of experience in the infrastructure sector. The company has developed more than 900 projects, each organizing 9 corporative departments, and its headquarters is located in São Paulo, Brazil. The project is a Brazilian consortium of an EPC contract formed by 2 main contractors and 1 subcontractor. The studied company is one of the contractors in charge of the design and construction teams involved in the construction of a thermoelectric power plant. The power plant is located in the city of São João da Barra in Rio de Janeiro state. The project scopes consist of the design, the procurement, construction, installations, commissioning, and starting up. Construction broke ground in March 2018 and is expected to finish in early 2021. Due to the market demand, BIM was incorporated as a part of the company's strategic plan. A team of professionals has been created and was divided in 2 different approaches. One focused on the development of BIM interface and other one of the expansion of BIM applications. Therefore, BIM process was designed to be implemented in 3 main phases. Phase 1 is structuring, focused on the studying of BIM. Phase 2, training, concentrated on investments on professional training, consulting, and BIM-related courses. And Phase 3, implementation of pilot studies. Standards and guides are being renewed and incorporated into the design process. New types of contracts are being developed based on LOD, design typology, and discipline. And according to the participants' opinion, BIM has impacted more in process when you compare to technology and people. In the beginning of the pre-construction phase, a multidisciplinary team has been working to increase the exchange of information between design and construction phases. Concerning the BIM model, it was developing mostly up to 3D and 1 4D phasing pilot study. Results have shown benefits from BIM adoption, such as better understanding of the design scope, more collaboration among stakeholders, more interaction with clients, exchange of information and knowledge management, design validation among discipline, cost estimation, and quantitative takeoff. Also, participants affirm that BIM has improved the design and construction interface by enhancing site layout, planning, safety, and reducing claims and risks. Findings also have shown a decrease in project fragmentation by promoting a better information management. The main obstacles with BIM implementation faced by the company were the achievement of a desired LOD, players' collaboration in the exchanging of information, lack of communication among stakeholders, lack of collaboration between design disciplines, lack of knowledge of the design team concerning the construction demands, being lack of knowledge on the behalf of the outsourced design company, lack of interoperability between software, and the elevated cost of investment in software and hardware. Based on our research goal, we understood that the main barriers with BIM are related to managerial problems than with BIM itself. We know that BIM implementation is an ongoing process in the company, and due to the short period of time of BIM adoption, these results were plausible and even expected. The construction industry is a complex and fragmented environment. In Brazil, the reality is not different. Not only the lack of trained professional with BIM skill is faced by the Brazilian construction industry, but also there is a lack of knowledge concerning the project and process management. Finally, it's important to say that the study has some limitations of methodological approach. First, as a single case study, the findings cannot be generalized. And second, the study was dependable on the participants' self-report perceptions. Thank you very much for listening to me.
Thank you very much, Lini.
Thank you.
The next paper will be presented by Yasser Alani, and the title is Whole Life Cycle Construction Information Flow Using Semantic Web Technologies, a Case for Infrastructure Project. Hi, Alani, be welcome.
Yeah, hello everyone. I am a PhD student at Teesside University. My supervisor is Professor Nash Dawood, and today I'll be presenting part of my PhD research. So in the water industry, particularly in the United Kingdom, there's a lack of mechanisms to efficiently capture, validate, and maintain the requirements of product information. For instance, when the company wants to buy a new pump from a supplier, what are the necessary attributes that the company should know in order to maintain the pump efficiently in the future? So one of the solutions proposed by some industry practitioners in the UK and adopted by several companies is the product data templates. And as you can see here, this is an example of a submersible pump template. And there's some consensus on these PDTs in the UK. But the supplier is required manually to populate these PDTs and submit it to the company. So as you might imagine, there's quite a manual work involved in the process. So we're looking at a way to combine these PDTs into a unified model, which would make things easier. And that's when we started looking at semantic hub technologies. And so the methodology was we're following a whole life cycle of information flow, which is basically the steady and continuous evolution and use of BIM information from the design all the way to decommissioning. And it basically consists of a set of guidelines to tackle such tasks. So it consists of 4 pillars: people, process, policy, and technology. And in this research, we're focusing on the technology side of things. And this is a simplified diagram that shows the process. Also, we focused on the RIBA Plan of Work, which is a document produced by the Royal Institute of British Architects as a guide to the life cycle of a project. It consists of 8 stages, and our model would aid project delivery mainly through stages 4 to 7, as you see on the picture here. So when the employer's information requirements are to be converted into a detailed properties. So semantic web technologies seemed promising, and so we decided to build an ontology using the PDTs as the schema source. And we called it the asset specification ontology. And the main class, as you can see here, or the center of the ontology, is the component class. So a component is any physical asset that is of value to the companies, or in other words, that could be replaced in the future. This slide here shows an example of the restrictions in the ontology. So an electromagnetic flow meter, which is a component, can either have an analog output or it doesn't. And when it does, we must know the number of outputs and the type of outputs. And here as shows the code of how we went about doing these things. Now, this is fine for logical inferencing, but the open world assumption assumes that information can be added at any time to the system, and so missing information is not treated as an error. So therefore, we used shackle rules to close the world in certain places. Shackle is a shapes constraint language. To put this work into perspective, this is the size of the ontology so far for 12 data templates. As you can imagine, they have a lot of axioms included in them. And so in total, there will be around 200 product data templates for the UK water industry. We're working together with them. So the ontology was deposited in GraphDB knowledge base, which in its latest update supports shackle rules, and so one can create the ontology for product data via Sparkle endpoint, and as well as obtaining validation reports. So this is a general overview of the work done. It was generally realized that researchers are optimistic on the capabilities of semantic optic technologies, at least in the construction industry. But at the core of semantic optic technologies is the open world assumption and the non-unique naming assumption, and changing these would change these technologies fundamentally. So if we were to accept the open world assumption and have distributed knowledge bases over the internet, data protection policies is another issue we face. So we're conducting this case study with a water company, and few water companies, as a matter of fact. And when we asked about the possibility of having access to having accessible knowledge bases, they didn't really like the idea. So at the time of writing this paper, one of the conclusions was the lack of standards that regulate publishing and capturing product information, particularly for infrastructure projects. But however, two new ISO standards that have just been published in April and July, as you can see here, they bring some improvements in this regard. At least that's what we expect. And as well, the initial idea was to use the ontology as a product catalog to query suppliers' databases, as presented in this paper, but that would require extensive mapping. However, with these two new standards, distributed data dictionaries for infrastructure assets are encouraged. So we will only be focusing on the common model, the ontology, in this case study, and test it further. Thank you for listening.
Thank you very much, Yasir. Great presentation. Next, Flávia de Souza with the paper Recommendations to BIM Approach for the Brazilian Infrastructure Contractor. Hi, Flávia.
Hi, how are you, Isato? Hello, everyone. The name of the paper is Recommendation to BIM Approach for a Brazilian infrastructure company. The authors are from Escola Politécnica, Fernanda, Aline is in this session, and me, Flávia. We have a context about the implementation in Brazil. We have a strategy, national strategy, and therefore we have a committee responsible to disseminate the BIM strategy. Yeah, and we have some technical studies on development process. And in this context, some public companies is taking the action to implement BIM, and we are speaking about one of them. The objective of my paper is to understand how a Brazilian infrastructure company has implemented BIM. It's a public company, part of São Paulo municipality, responsible for urban projects, medium and big projects, and responsible for urban special assets in São Paulo city, such as viaducts, bridges, and etc. All technical services are outsourced. About methodology, we have two fronts of work. The first front of work is a case study done in the infrastructure company. The second front of work is a survey, which was applied with contractors and designers who work for the infrastructure company. The results of this study is recommendation for the study company, and our references are the guidelines and best practices for BIM implementation around the world. About the case study, the company started implemented a PMO in 2017. And among the PMO actions, there were a BIM laboratory. And the first step of this PMO was to carry out a diagnosis. And the diagnosis basically aims to diagnose the current practices of project management of the company and nuances, and map the macro process of the company. And they would like to answer the question, how can we support the company operation, and what are the main issues of the company? Basically, about the diagnosis, the main issue of the company lives in the relation among scope, guiding process, and reference term. The reference term is not defined accordingly because the scope problems caused by small time to bidding process. And what they do expect about the BIM, basically add value for everything. Add value for BIM bidding process, add value for project management process, bring some transparency to the process. Along the diagnosis, the company defined a set of actions and their benefits. Some of them are in progress, some didn't initiate it yet, and some are completed. The first one is improving the scoping process of the company. About the survey, the sample was a such of representative one, we believe. You have professionals with different educational backgrounds, and most of them are architects and engineers. Most of them are owners of the companies or have managerial and price roles. The first question we did in the survey, what is BIM for the respondents? And it's a multiple choice question, and all of possibilities are possible to be chosen. Interesting note that most of them believe that BIM is a process focused on information to support project management. About their stage in BIM implementation process, hopefully most of them are on the road about implementation process, and unfortunately 13% they don't have BIM implementation in their plan. About the relation with these companies and the company which is implemented being the main client, 23% is not aware about the implementation. It's a problem to solve to the company. And we compared the guidelines and the company planning, the infrastructure company plan. There is a set of actions that were incorporated in the company planning, but it's interesting to note that the company doesn't have a business case, being project execution process, and they didn't define it yet a pilot project. Okay, in the other words, they are partially defined as a pilot project. When we analyze the company's action with the designers and consultants' expectations, hopefully most of them are coincident, and they have about the designers and consultants, they have a great expectation to be involved in the process. They are really worried about the information expectation from infrastructure company side, and they're really worried about contracts and general rules about contracting. They fully agree about the benefits defined by the company, and they fully agree about the benefits of being about project management benefits. About our conclusion, it's really positive. The company starts the implementation process by a diagnosis, departing from the problems, reflect how about could add value for this process. And in the final, we recommend a set of actions for the company, but we believe that implementation process in a company as such, the company that we studied must take into account that the implementation process refers to internal and external aspects, and the communication, it's a really important process. Thank you very much.
Thank you very much, Flavia. Thank you for your presentation. The next presenter will be Ali Alio-Bawano. Did I spell correctly?
Yes, correct.
Yes, and the paper is a study of building information modeling implementation on railway infrastructure.
Yes, thank you. Hello, everyone. Hello, Mr. Chairman, Eduardo Isato. Today, I would like to present a study done by us with my friend Christian Maximilian von Schumann and my professor Bernhard Lechner in the Technical University of München. And the topic is a study of building information modeling implementation on railway infrastructure. And here is the outline. First of all, we'd like to start with introductions, methodology, and then the characteristics of respondents. And then I will share some results, including issues, challenges, opinion, key challenges, and conclusions. Next, please. So for introductions, we did a literature before we conducted the survey, and here are some findings that we found out. So 12% of the contractor in France, Germany, and UK have been using BIM for at least 6 years or more, as well as in the US and Canada. And South Korea contractor shows at least 65% BIM adoptions. And in Singapore itself, the BCA authorities has implemented BIM roadmap since 2010. But then many companies are facing challenges when it comes to BIM implementation in railway. So here are some reasons, including like, for example, high environmental requirements, complex network topology, very high requirement on the track geometry, a big number of different supply divisions, requirement on the traction to the network, and also to the rolling stocks. And so to understand better about BIM implementation, we developed the study and also the scope. So here is the scope. So we do a survey based on the semi-structured interview method. And then we made a questionnaire to understand the perspective of contractor or user in BIM. And then we try to address some key challenges, including technical, personal, and process aspects. And then we try to get some answers from the right person, including managers and engineers who are responsible. And then next, to simplify, this is our methodology. So first of all, we set the objectives and then survey frame, and then we met the questionnaires. But then before we conduct the real surveys, we try to validate by sharing our questionnaires to the users, and then we see if the questionnaires is valid for the answer and as well as the companies. And once the questionnaire is valid, then we spread more to get more answer and data. Next, please. And then here are the structure of the questionnaire. So we try to ask general questions, including BIM usage, BIM standardization, the software they're using, and then benefit challenges they are facing, and also their opinion about BIM implementation in railway. And next, please. And here is the summary of the respondents. So there are five big companies included. However, they are classified. Has more than 2,250 employees. However, the numbers of engineers in railway department is various. And then even one company does not have specific department for railway works. However, most of the respondents has more than 4 years experiences. So here are some of the results. I just highlight some of the important results. That first, in the percentage of the model, for companies, at least they are doing a 3D models in the majority of works is the railway. Only one less than 50%. And secondly, they are quite satisfied with the software with some notes for the buildings and alignment with related applications. And secondly, here another research related to satisfactions. So some companies mentioned that they are not really satisfied as it is very time consuming to do BIM modeling in railway. And then there are very limited model standards for railways. And then next, as for the data exchange, most companies are using PDF and the DWG file. And then mostly are using internal server to exchange data in the company. Only one company is using a central servers. But further, they are expecting to have a better data exchange platform for the future. And next. And for the file format, challenges are found that there are no proper interface solutions. And then companies A, B, and C reporting huge data loss due to these issues. And then next. And most companies expected to get a clear guidance and assistance from the client. At least they are expecting a guidance. And then they are expecting a level of details that need to be specifically explained from the beginning of the project to avoid some issues. And next. And then here are some benefits shared by the users. Most of the companies, they are sharing their benefits, including visualizations, and then communication purpose is easier, and then continuous design process, data accessible, and then they can do a class detection in early, and then reducing error, and also better interfaces. And then some challenges, including how to motivate employees to shifting mind. And then they also say that they are need support from the client. And then they are also saying that they are facing a challenge transition from 2D to 3D. And then here are the summaries. So 50-50 for explanation that for BIM is already good for railway, but they are believe that BIM in railway can be improved, and BIM is not sufficiently standardized in railway. And here are the key challenges that have been summarized. They are about technical, personal, and process. And for technical, they are including handling of growing file sizes, and lack of standardized data exchange, lack of proper design software. And then for personal challenges, including change attitude and mindset of the people or the engineer, and then how to motivate the engineer to using BIM, and to have some understanding of BIM within the whole project team. And for the process, the big challenges including the transition from 2D and to 3D design characteristic, and absence of standardized data exchange, and then BIM is only working if the client is completely confused to use BIM. And for the conclusions, next, there are 3 types key challenges in BIM implementation for railway, including technical process, and then satisfaction on the type position in developing BIM for railway is arguable. 3 out of 5 companies that it is very time consuming, but at least all respondents agree that BIM offers benefit and it should be used for railway projects. However, BIM is not really great, but they are convinced that it can be improved. Thank you.
Thank you very much, Ali. Thank you for the presentation. The next presentation will be from Robin Dragmuller, a strategy for defining an interoperability layer for linear infrastructure. Hi, Robin. How are you doing?
Hi, Eduardo. I'm having trouble sharing my screen.
Yeah.
Yeah.
Technical issues again.
Yes. Should I change over to Chrome? Yeah. Should I change over to the Chrome browser?
Robin, I can screen the slides if you are not able.
Yes, please. That would be simpler.
Just waiting to download.
Yeah. Okay, hello everybody. Thanks for joining the presentation. So I'm presenting on the strategy for defining an interoperability layer for linear infrastructure. This is looking at some of the work going on within Building Smart in their infrastructure program. So you can see the names of my co-authors there, and this research is supported by an Australian Research Council grant. Next slide, please. So in Brisbane, we have a number of infrastructure projects going, including the Brisbane Metro articulated busway shown with the solid green and the blue lines. We've got the Cross River Rail project, which is the dotted lines. All of these are using tunnels that go underneath the Brisbane River, and these also articulate into the busway articulates into the road infrastructure, and there are also 3 major road tunnels in Brisbane. So just for one city, we're covering off on fairly massive infrastructure projects. Next, please. So if we look at the IFC model, next. There we have down the bottom, we have the core layer and the resource layer. Next. And above that is the domain layer. So in the domain layer are all the objects that you see when you're actually manipulating a BIM model. Next. And between these 2 layers is the interoperability layer, where we pick up objects that are shared across multiple disciplines. So this enables the collaboration between disciplines. Next. So with infrastructure here, we have a road and rail. We have major electricity cables supplying the railway and also the lighting on the roads. There are signals and so on, and also the surrounding urban infrastructure. Next. And these infrastructure meets at locations such as this railway crossing, where we've got the road and the rail. We've got some boom gates for traffic control. We've got a signage and also signalling systems. So these all need to be covered. Next. And then they also meet buildings. So here's the railway station, a new railway station being constructed for the Cross River Rail project. So we need to be able to integrate these infrastructure projects with BIM, building BIM as well. Next. So within Building Smart, these are the current infrastructure projects running across the top. We've got a rail, road, bridge, ports and waterways, and also the tunnel. Next. And then this is the common schema sitting underneath that needs to be defined from all these 5 existing working projects. Next. So some preparatory work was needed to be done. In the original Building Smart model or ICM model was originally aimed at buildings, where we were looking at the floors and so on. With infrastructure projects, they're more interested in alignment. So there was a lot of work done on defining alignments, initially just with road, bridge and tunnel modelling. Next. This was expanded up to cover the other projects. So if you look at IC Rail and the different factors they identified or systems they identified. Next. The ones that are specific to rail are sleepers, ballast and rails. Next. All the others are across a number of other infrastructure projects, and then you can see tunnels are there. That's actually a completely separate infrastructure project. So you can see the interrelationships here. Next. Right. So in the process, they pull out some of the objects they're proposing. So they're looking at a boom barrier and a turnstile being examples of IC door from the existing model. Next. But turnstiles are used across a whole range of different facilities. So this isn't an object that's just going to stay within the rail project. Next. So if we look at the planning, so next. The common schema there, that's all earthworks and geotechnical, which is going to be needed across the entire infrastructure project. Next. We also note that railway crossings and cityscape and the urban surroundings are out of scope. So this isn't actually going to cover everything. It's just a start in looking at roads and infrastructure in general. Next. With the tunnel project, we've got the 3 underlying factors there: lighting, drainage, power supply. These are also shared across other infrastructure systems. Next. And then we have an example here of some power cables that need to run underneath the bridge in a major new highway project. So here the only information they needed to know about the electrical system was the geometry to do clash detection, but you can see how critical the cross relationships between different types of infrastructure are, even infrastructure that's not yet defined, such as electrical distribution. Next. So across all of these individual projects. Next. They've done a lot of work defining the specific objects that are needed to service their particular area of interest. Next. And then from these, we need to pull out the shared objects and attributes that are needed to exchange data between the different projects. Next. And we also need to look ahead and plan for other things such as electrical distribution. And obviously, if you're looking ahead for things that aren't yet defined, you're going to make mistakes or make decisions that aren't necessarily the optimal. So you need to make sure if you're going to make mistakes, you actually make them for good reasons. Next. So for the interoperability layers, the type of objects we are going to be building. And next. There'll be some common objects such as fences and signage, which are used all the way through. So there'll be objects in the interoperability layer that can actually be used directly in CAD systems or BIM systems. Next. But there'll also be some abstract objects So if we look at the different types of bridges, a road bridge has a bitumen deck, a railway bridge may just have sleepers laid across with the rail, and the footbridge would have a pedestrian type surface. So there may be abstract, there may end up an abstract object bridge, which is then instantiated in more detail in the domain layers above. Next. And then, as we've seen in a number of presentations, the amount of information we know increases with time. So we also need to look at how the range of attributes will increase or change over the duration of the project. Next. And then if we look at all of these schemas or projects, there are some dependencies between them. Next. So we've got IC bridge and IC tunnel. These are needed for almost all infrastructure projects in some way. Next. So road and rail need to use both bridges and tunnels. Next. And then ports and waterways will often need to interface with road and rail. Next. And then there's the airports project, which is actually outside of the infrastructure group. They have their own group, but they also need to use a lot of this information as well. Next. So next. So our goal is to be able to pick up all of the objects that are represented in this image. And next. And your railway crossings and all of that. Next. And also to be able to interface with buildings. And if you reflect on complex building sites, just within a normal building project, everything outside of the envelope of the building actually is very closely related with infrastructure. So the infrastructure work will feed into identifying site works around normal building projects as well. Next. So thank you very much for your attention. Here's the contact details for the researchers who worked on this work. Thank you.
Thank you very much, Robin. So this is the last presentation. So now we have a question and answer slot. We have some questions, and I ask for, if you want to ask questions, please write on the comments bar at the side, numbering the number of the paper. Okay, I'll start. So there are many questions, so I'll start by the post order. The first one is from Flavia to Stefania. Integrate BIM and risk is a complex task, mainly because we do not have the culture of risk disseminated in Brazil. How do you evaluate it, and also adding barriers referring to technology?
Yeah, Flavia, thank you for the question. I agree with you. That risk management presents challenges regarding the use of technology. But I think that using BIM, we can not only offer the participants the opportunity to collaborate and discuss the risk of the projects. So even though there is this barrier regarding risk management and this culture of risk management, not only during the operation or the construction phases, but also during the bidding stages, I think that by using BIM, we can foster this culture. We can enable these discussions, and naturally people collaborating, they could improve, create this culture of risk management.
Okay, thank you. From Pedro Meda to Sarah. The BIM objects set for the project are just composed by geometric data, or do they support other characteristics? If yes, are they following the new ISO standards related with data templates? Your mic is muted, I think.
Sorry again. Thanks for the question, Pedro. These objects are being developed by Metro de São Paulo, and in the research, we are considering budget data and the company codes. And in this point, in the research, the objects don't follow any classification standard, only the Metro de São Paulo rules.
Okay, thank you. Another question for you from David Furstenberg. You showed a slide containing cost information. Was the model used for automatic cost estimation?
Okay, we are using the software ArchiCAD to model the meta component, and iterations with reference table are being done by itself in the ArchiCAD. This is a very challenging that we are developing yet in the research. But thank you for the question, David.
Okay, thank you. The next question is for Stefania also, from Matthew. BIM for tendering might shift liability to ARC and because contractors rely less on their expertise and interpretation when analyzing plans? The question. Data could be blindly extracted solutions?
Well, Matthew, thank you for the question. I think that responsibility over the development of the BIM model has to be shared. We cannot put this responsibility over only designers, architects, and engineers, blindly extracting information by the contractors. So I think that contractors has to share their knowledge with the designers, with the architects, with the engineers, and not only share the knowledge, but also checking the information that the designers are sharing with them through the model. So, in my opinion, everyone has to be co-responsible, even the owner, in some cases, by the information put into the model. So I do not think we could blindly extract data from anything without checking. So my opinion is that responsibility has to be shared by all participants during the project. Okay, I don't know if I answered, but.
Thank you. And the next question is for Aline, number 8, from Pedro. Thank you for the presentation. You mentioned that BIM is more process than people and technology. I'm not saying that I agree or disagree. I would like you to better explain better this.
Yeah, first, thanks for the question. What happened during the interview process? The participants were asking if I put 3 categories, such as technology, process, and people, which one the participants consider the most impacted by BIM. And the majority answer, it was process. If you compare to people and technology, it was the most impacted by BIM.
Okay, thank you. I have also a comment and also a question for Robin. It's impressive the complexity involved with the thing of using BIM in infrastructure projects, because there are a lot of different components and areas and types of infrastructure projects. So I think that's great, this idea of work with interoperability layer now, but what is behind this? Is there an intention to release specific versions of IFC target to specific domains or areas of infrastructure projects? Or the idea is to wait to have IFC 5 for everything? What is your opinion on this?
Okay. The need for an interoperability layer was recognized way back in 1995 in the first development of ICs for buildings, where you have discrete disciplines. If we waited until we had an IC for everything, then I'd be dead before then, and I'm not prepared to wait that long. So once again, it was recognized fairly early, about 15, 20 years ago, that we needed to have specific foci around particular exchange scenarios. So the work was done on the identifying the industry needs and also defining what are called model view definitions. So the model view definition defines which objects needed to be exchanged between particular disciplines at a particular time. So that's just to reduce the scope of objects need to be supported by particular software vendors, but also reduce the load on the people actually working with the software in understanding what's going on and how to work with it.
Yeah, As the presentation of the paper showed, there are very high expectations to have solving the problems of interoperability in this kind of project. There's a question from I think that is from Toledo, that I was afraid to ask this question, but now the question is here. Is there a defined time frame for a new IFC for infrastructure to be released?
Yes, there is. There is some is going to be in some of the updates to version 4 of the IFCs, which is the current one, and then some of them are going to be coming in within IFC 5. Building Smart held an online technical workshops in the middle of the year. If you go to the Building Smart website, you can actually link to all the presentations and the recording of those presentations, and they actually give the explicit planned timelines for each of these individual infrastructure project types. I can't remember all the dates off the top of my head.
Oh, thank you very much. Any questions more? No? So thank you very much for the presentation. I think the session was great. It was very interesting to see the discussion on these two topics, that is being infrastructure and also cost estimating and planning. So I'd like to thank you very much for the presentation and all the people who the assistance. So you end the session now, and thank you very much for everyone.
Yeah, thank you, Eduardo.
Thank you.
Thank you.